Hi guys, in this video we're going to hit 5.3 part 1, and so what we're going to look at is how to tell where functions are increasing and decreasing, which is going to help us find a local min or a local max. So this is called the first derivative test, but if f prime is greater than 0, and then it switches to f prime being less than 0 at a critical point, that is a local max. So I'm going to kind of phrase this in a little nicer language. So we're going to say, if we have a critical number c, and f is, we'll start with this one, we'll do increasing to the left and decreasing to the right. So if we kind of look at this, increasing to decreasing, that becomes a local maximum. Okay, so this one says for a local min, so if f prime is less than 0, and then switches to greater than 0 at c, where c is our critical value. Okay, so it goes from decreasing on the left of our critical point to increasing on the right of our critical point. Then this, so decreasing to increasing, that switch happens at a local minimum. Okay, so we're going to do a couple examples where we're finding local extrema, so local mins or local maxes. Okay. So first we're going to do what we've been doing already. We are going to find our critical point. So we're going to set f prime equal to 0 because this one has no places where it does not exist, right? This exists everywhere. So I'm going to find the derivative, minus 12x squared, and then I'm going to set this equal to 0. I'm going to go ahead and factor out 4x squared, and then I'd be left with x minus 3. So setting each of those equal to 0, we'd get 0. And 3 for our critical numbers. So these are our critical numbers. Okay, so this is now where I kind of like to make that sign chart. So my critical values happen at 0 and 3. So I want to find the sign of f prime, something less than 0, something between 0 and 3, and something greater than 3. So I picked these three values. So I found what's f prime of -1, f prime of 1, and f prime of 4. So if we substitute these three values in to our derivative function, we just care about the sign. What do we get, positive or negative? So when we substitute in -1, so something in this range, we get a negative output. When we substitute in +1, we also got a negative output. And then 4, we got a positive output. Okay, so remember, we are looking for when is it switching from negative to positive or vice versa. So it's staying negative, and then here it switches. So it switches at 3. So that means 3 is either a local min or a local max. How I decide is it goes from negative to positive. So remember, this is decreasing and increasing. So when it switches from decreasing to increasing, that's a local minimum. So we would say we have a local min at x equals 3. Okay, now we could also find the exact point of this. So we could say this is going to happen at 3f of 3. So I can actually plug in 3 into my original function and get the y value that goes with it. So let's see, we do 3 to the 4th is, I think, 81. Check my math here. 3 to the 4th is 81 minus 4 times 3 cubed. Which happens at -27. I don't think that's right. Sorry. We're doing 3 to the 4th minus 4 times 3 to the 3rd. Okay, so I'm doing 3 to the 4th, and we get 81. And then 3 to the 3rd times 4 is 108. So 81 minus 108. Oh, minus. All right, that's -27. So that gives me the y value. So then this is where the local min occurs. So there is no local max because it never goes from positive to negative or from increasing to decreasing. Okay? All right, so let's try number 2. So we're going to do the same thing. We're trying to find any local mins or maxes. So we're going to start the same way. We are going to find the derivative and set it equal to 0 and possibly look at where it's undefined. So I'm actually going to distribute this x to the 2/3. So this I can think about x to the 3/3. So I add those exponents when I multiply. So this becomes x to the 5/3 minus 5x to the 2/3. So this is still just f. Now when I find f prime, I can use the power rule. So I'm going to get 5/3 x. Okay, minus 3/3 is going to leave me with 2/3. Okay, minus, we get 10/3 x to the negative 1/3. Okay, so this also, I think it's something you guys did in pre-calc, but I can actually factor this. How we factor this whenever I have a negative exponent is I always take out the smaller of the two. Also, I can take out 5/3 because 5/3 goes into both those. So I'm going to factor out a 5/3 x to the negative 1/3. Here's what would be left. So if I subtracted negative 1/3, that's really the same as adding a third. So this is going to become just x. And then when I divide this by 5/3, I'm just left with 2. And I factored out that negative 1/3. So you guys can kind of check this. So if I distributed this back, I'd end up right back here where I started. Okay, so we're setting this equal to 0. And actually, before I do that, you guys, I'm going to actually go one more step. I'm going to rewrite this as a fraction. So I'm going to get 5 times x minus 2 over 3, right? 5's in my numerator, 3's in the denominator. This goes to the denominator. Okay, so I'm looking for where does this equal 0 and where does it not exist. So it equals 0. So f prime equals 0 when x is 2. So when my numerator equals 0. Okay, it's undefined, so f prime does not exist when x is 0, right? Because I'd get division by 0. So that means 2 and 0 are my critical numbers. So I'm going to set up my sign chart. So let me write that actually here. Critical numbers are 2 and 0. Okay, so I'm going to, again, do my sign chart. So I'm looking for number less than 0, between 0 and 2, and then greater than 2. So, again, I'm looking for f prime. What is the sign of f prime here? Okay, so I went ahead and picked some numbers already, you guys, and I got positive for numbers less than 0, negative between 0 and 2, and positive greater than 2. So, again, what we're looking for is where do I have local mins and maxes. Okay, so I switch from positive to negative. So another way I can think about that is I switch from increasing to decreasing. So this is a local max. So we have a local max at 0. Now, again, we want the y value that goes with this. So if I plug in 0 into my original function, I get 0 times something, which is just 0. Okay, local min. We have when it goes from negative to positive or from decreasing to increasing is a local min. Okay, so we know our x value that happens at is 2, and then we can plug 2 into the original function to get the y coordinates. So we're going to do 2 raised to the 2/3, right? And then times 2 minus 5 is negative 3. So we get about negative 4.762. So that is where the local min and max are happening. Okay. All right. Another thing that we're going to practice a lot in this unit is looking at a graph of a derivative and determining what that tells us about the original function f. So this is the graph of the derivative. Okay. So this is f prime. Determine the critical numbers of f. So remember, this is where f prime of x equals 0 or does not exist. So this one doesn't have any asymptotes or holes, so there's no spot where it does not exist. But where does this equal 0? Well, right here and right here. So at x equals 2 and 0. Where is f increasing? So f is increasing when f prime of x is positive. So I'm looking for when is f prime above the x-axis. So it's only above the x's from 2 on. So 2 to positive infinity. Remember, we're using parentheses for all of our intervals of increase and decrease. Okay, where is f decreasing? So we look at where is the derivative negative. So I'm looking for where is it below 0. So I'm actually going to put negative infinity to 0. And I'm actually going to kind of separate here because I do have a critical number that happens here. So I'm going to write these as two intervals. So I have like 0 as a point where it's no longer increasing or decreasing. It's like the point where it switches. So we're not going to include it in either. We're going to start a separate interval. Okay, so it's less than 0 up to 0, and then stays less than 0 to 2. Okay, so these would be the two intervals of decrease. Okay, where does it have a local minimum? So this is where we look for when does it change from increasing to decreasing. So it went from it goes from decreasing to increasing. Sorry, I did that wrong. It's decreasing this whole time up to 2, and then it switches to increasing at 2. So if it goes from decreasing to increasing, that means we have a local min. Decreasing to increasing is going to look like that. So I have a local min. So we're going to say, I'm going to write this out so you guys can see. F, right? We answered some questions about F and B and C. So F changes from decreasing to increasing at x equals 2. So there is a local minimum at x equals 2. Now, we can't give the y value in this case because I don't have a function to plug it back into, so we're just going to say the x value. So there's a local minimum at x equals 2. Okay, does it have a local max? So this is when it goes from increasing to decreasing, and that never happens, okay? So we're going to say there's no local max, and I'm going to write the reason why so you have it in your notes. No local max, because our function f never goes or never changes from increasing to decreasing. All right. Okay. This next problem we're going to do is going to deal with motion. You guys have a few problems like this in your homework. So some of this is review, but when our velocity is greater than 0, we are going to be dealing with some motion along the x-axis here. And so we're going to say that the position is increasing. So in other words, we can say like the distance from the starting place is increasing, and it's going to move to the right if our velocity is positive, okay? If our velocity is negative, our position is decreasing and it's moving to the left. If our velocity equals 0, then the object is at rest. And remember, speed is the absolute value of velocity, just as a reminder, okay? So if speed, we want to know if our speed's increasing or decreasing. So velocity could be positive or negative. Speed is always positive, but we can tell if our speed is increasing if our acceleration and velocity have the same sign. Okay, so we're going to say it's increasing when that happens. When my acceleration and velocity have different signs, our speed is decreasing. Okay, so we're going to do a problem kind of utilizing this motion along the x-axis. All right. So we are given this function, an object moving along a horizontal line, so kind of the x-axis. Its position is x, and we're looking at what's its position from the origin for time greater than or equal to 0 in seconds, and here's our function. So this is my position function. Determine the intervals when the object is moving to the right. So remember, this is going to happen when velocity is positive. So I'm going to do a little work here, and remember, velocity is the first derivative of position. So here's my position function. I'm going to take the derivative. That's going to give me velocity. Okay, so taking the derivative here, we get 3t squared minus 18t plus 15. Okay, so we're going to do what we've been doing. We're going to find critical numbers and then use our sign chart. So I'm going to set 0 equal to this guy. I'm going to go ahead and factor out the 3 already. And then what I have left there, I'm going to be looking for numbers that multiply to be 5, that add to be negative 6. So that's going to be negative 1 and negative 5. Okay, so then I set these equal to 0, and I get t is 1 and t is 5. Okay, so now I'm going to kind of look at my sign chart. So we got 1 and 5. I remember we're starting at 0, so I got to look at something between 0 and 1, between 0 and 5, and then greater than 5. Okay, so when I plug these numbers in, and again, we care about the velocity sign, so I'm going to pick numbers and plug them into this function. When I plugged in something 0 to 1, we got a positive output. 1 to 5 was negative, and then 5 on was positive. Okay, so remember, when is the object moving to the right? I'm looking for when is our velocity positive, okay? So this is happening for these intervals. So it's positive from 0 to 1 and 5 to infinity. So that is when it's moving to the right. When it's moving to the left is when our velocity is less than 0 or negative, and that's happening between 1 and 5. Okay? When does the object reverse direction? So it's moving to the right to start, and then it switches and goes to the left, and then it switches and goes back right. So it's going to switch 2 times to change from right to left. So it's going to switch at t equals 1 second and switch another direction at t equals 5 seconds. Okay? So draw a figure that illustrates the motion. Okay, so here's what we're going to do is I'm going to put x, so our position, okay? And we're starting, I'm going to actually use my original position function. So if I plug in 0, I'm going to do that right here, I get 3. So that means when time is 0, my object is 3 away from our starting position 0, 0. So this is at time equals 0. And then it goes, so I'm going to just write that t equals 0. And then it moves to the right up until 1 second. So if I want to find like what's the position at 1 second, I can also evaluate what's x of 1. So if I plug in 1 right here, I get 10. So then 4, 5, 6, 7, 8, 9, 10. So then at 10, it's going to switch direction. So this happens at t is 1 second. Okay, then it's going to switch direction. So I'm going to kind of drop, and it's going to start going left. So it goes left until 5 seconds, right? So if I want to find what's my distance at 5 seconds, I can also evaluate what is my position at 5. When I do that, you get negative 22. So it's going to go all the way down here to negative 22. And then after 5 seconds, right, so this is at t equals 5, and then it's going to switch and go back right forever. So that would illustrate the position of this function. So notice, though, I had the times from up here, right, 0, 1, 5, but to actually find where the position is changing, I can plug those values into my original position function. All right, when is the velocity increasing? When is the velocity decreasing? Okay, so when the velocity is increasing, okay, this is where, so these ones were when is position increasing and decreasing. When I want velocity increasing, I'm actually going to use the second derivative. So I'm actually going to write it like this. So the second derivative of position, or the first derivative of velocity, is acceleration. So we are looking for when is it increasing, when is it decreasing. So increasing is going to be when a of t is greater than 0. Decreasing is when a of t is less than 0. Okay, so I'm going to evaluate what is, oh, sorry, I put a prime there, it shouldn't be. Okay, so our acceleration is the derivative of velocity. So here's velocity. We're going to take the derivative of this, which is going to be 6t minus 8t. Okay, so I'm going to actually do the same thing. I'm going to essentially find my critical value for this. So I'm going to factor out 6. So I get t equals 3 is our critical number. And this is the critical number of the velocity function, okay? So now, when I do my sign chart, so this is for a of t. Okay, we are looking for what's happening to the left of 3. Again, I have to be positive. And then what's happening to the right of 3. So when I've evaluated numbers here, When I put in something between 0 and 3, we got something negative. Okay, when we pick something bigger than 3, we get something positive. Okay, so when our acceleration, so I'm going to write it like this, a of t is less than 0, which means our velocity is decreasing. For 0 to 3. Our a of t is greater than 0, which means velocity is increasing. From 3 to infinity. Okay? Draw a figure that illustrates the velocity. So we're going to draw something a lot like this one, but this is for velocity, not position. So I'm going to do v here. Okay, so again, kind of my starting position 0. So if I plug in 0 to our derivative function, sorry, I got to find it right here. Here's our derivative function. So if I evaluate v of 0, I get 15. And then 3 is kind of this number where it's a critical value for the velocity. So I'm going to also evaluate what's happening there. Where am I? V of 3 is negative 12. Okay, so to kind of get these, so I'm starting with a velocity of 15 right from the get-go when t is 0. And then our velocity is decreasing for 3 seconds. Okay, and then I have a velocity of negative 12 at t equals 3. So at this point, t equals 3, and then it's increasing from 3 seconds on. Okay, so that kind of illustrates, starting at velocity of 15, my velocity is decreasing, and then it starts increasing again at 3. Okay, last two. When is the acceleration of the object increasing? When is it decreasing? Okay, so notice each time I'm like taking the derivative. So if I want to find when the acceleration is increasing, I actually want the derivative of acceleration, and I want to know when's it greater than 0 and when is it less than 0. So we're looking at these. So this would be increasing, this would be decreasing. So if I find a prime, so my acceleration function was right here, 6t minus 6, I get just 6. So this is always greater than 0. So since a prime of t is always greater than 0, the acceleration is increasing for always. It's always increasing. The acceleration is increasing from 0 to infinity. Okay, now determine the speed of the object and when it is decreasing. So I'm going to use this, you guys, when this is from the previous page, but when my acceleration and velocity are the same sign, my speed's increasing. When a and b are opposite signs, it is decreasing. Okay, so I'm going to look at, so increasing, so speed is increasing when a and b have same sign. Okay, so where does that happen? So they're both positive or both negative. Okay, so I can look right here at my sign charts. So A, let me look at these two. Okay, so here's A. So negative from 0 to 3. So there's some overlap with negative between 1 and 3 then. So they're both negative between 1 and 3. Okay, so that means from 1 to 3. And they're both positive. So here I have positive greater than 3, positive greater than 5. So 5 on, they're both positive. So that is when they have the same sign. So there's my two intervals there, you guys. So they have the same sign between 1 and 3 and 5 infinity. So speed is decreasing when A and T are different signs. Okay, so where does that happen? Okay, well, if I look again at my sign charts, so here's velocity and here's acceleration. So it's positive from 0 to 1, and it's negative from 0 to 1 here. So that is when they are opposite signs. So I would say they are opposite signs 0 to 1. Okay, when else are they opposite signs? Okay, well, I'm negative all the way up until 3, but I switched to positive after 3. So between 3 and 5, they are opposite signs. 3 to 5 is negative here, 3 to 5 is positive here. So 3 to 5 would be my other interval. All right, guys, that's all for the 531 video. Thanks for watching.